Saudi Arabia is one of the driest nations on Earth. More than 95% of the country is desert. Rainfall is extremely low. Summer heat can rise above 45 degrees Celsius, and natural freshwater is limited. Yet millions of people, industries, farms, and entire cities still need water every single day. So Saudi Arabia built something extraordinary, an invisible river made from steel. Instead of waiting for rain, the country pulls seawater from the coast, removes the salt, treats the water, and pumps it deep into the desert through giant pipelines. The system begins offshore. Large intake pipes are placed in the sea where water can be drawn in continuously. These pipes are lowered into position and anchored to the seabed, so they can handle constant hydraulic pressure. Before the seawater reaches the desalination plant, it passes through protective screens. These screens block floating debris, seaweed, jellyfish, crabs, and small marine life from entering the system. Without this first barrier, the pumps and filters inside the plant could quickly become damaged. Once the water enters the plant, the cleaning process begins. The seawater is still full of sand, sediment, and tiny particles, so it first moves through large filtration tanks. Water passes through layers of sand or filter media, trapping suspended material before it can move deeper into the system. Then chemicals are added to make the smallest particles clump together. This process is called coagulation, and it helps fine dirt and microscopic solids settle or filter out more easily. After that, the water passes through cartridge filters. These are tightly packed filter elements with tiny pores, often just a few microns wide. Their job is to catch the last particles before the most important stage begins. Reverse osmosis. This is where seawater becomes fresh water. Salt cannot be removed by ordinary filters because the salt ions are far too small. So the plant uses high-pressure pumps to force seawater through special membranes. These membranes allow water molecules to pass through, but they block most of the salt and impurities. To make this happen, the pumps can push the water to around 60 bar of pressure, roughly 60 times normal atmospheric pressure. At that level, the system can separate water from salt at the molecular level. In many plants, the water then passes through a second stage to remove even smaller traces of minerals and dissolved ions. By the time it exits this section, the water is extremely clean, but it is not finished yet. Pure desalinated water can taste flat, and it may not have the right balance for drinking. So the plant adjusts the pH and adds back small amounts of minerals such as calcium and magnesium. This process is called remineralization. It improves the taste, stabilizes the water, and makes it suitable for homes, businesses, and public use. But producing clean water is only half the challenge. The bigger engineering problem is moving it. Many Saudi cities and inland communities are far from the coast, so fresh water has to travel across long desert distances. To do this, the country relies on huge carbon steel pipelines, similar to the pipelines used in the oil and gas industry. These pipes are built to handle pressure, heat, ground movement, and harsh desert conditions. The process starts in a pipe factory, where thick steel plates are cut to exact dimensions. The plates are rolled into circular pipe sections, welded along the seam, cooled, ground smooth, and shaped with beveled ends so each section can be joined accurately in the field. Every pipe must be strong, straight, and properly coated before it is sent to the construction route. From the storage yard, the pipe sections are lifted onto transport vehicles and carried to staging areas across the desert. There, construction teams arrange them in the order they will be installed. Survey crews then mark the exact route using GPS, terrain data, and ground stakes. This matters because the pipeline must avoid unstable soil, shifting sand, erosion zones, and difficult terrain wherever possible. Once the route is prepared, heavy machines clear the land and open temporary access roads. Excavators then dig a trench wide and deep enough to hold the pipe safely underground. Before the pipe goes in, the trench is prepared with a bedding layer of fine sand or screened soil. This cushions the pipeline, spreads weight evenly, and prevents sharp rocks from damaging the protective coating. Then the steel pipe sections are lined up and welded together. Special clamps hold the pipe ends perfectly aligned while welding crews join them. After each weld is complete, inspectors use ultrasonic testing to search for hidden cracks or defects inside the joint. After inspection, the field joints are cleaned and coated with protective epoxy. This helps prevent corrosion when the pipeline is buried. Finally, side boom tractors lift the long pipe string with padded slings and lower it into the trench. Several machines work together so the pipe does not bend, twist, or scrape against the trench walls. Once the pipe is in place, the trench is backfilled in layers and compacted. When the system is complete, pumping stations push the treated water across the country. These stations are the muscles of the network. They keep water moving over long distances, through elevation changes, and across one of the hottest environments on the planet. What Saudi Arabia has built is not just a desalination plant or a pipeline. It is a complete water supply machine. The sea provides the raw water. The plant removes the salt. The treatment system makes it drinkable. And the pipeline network carries it across the desert to the people who need it. In a country where natural fresh water is scarce, this engineered river has become one of the most important systems holding modern life together.